Hi, everyone. Good afternoon, or good morning, I should say. My name's Ed. I'm a core contributor on OpenFaaS, and I do this kind of work at the weekends, at night time, when my wife is watching television. Sometimes I do it when my daughter's having her swimming lesson or riding a pony. It's not my pony. This doesn't pay very well. But for my day job, I'm a platform architect at Form 3, a fintech back in the UK. And I'm not doing this for a selfless reason. We use this software at Form 3, and I want to use it more and more at Form 3. So I had a bit of work to do because we use Lambda quite a bit at Form 3. So this is our session today. We're going to start by seeing just how easy it is to extend OpenFaaS to support different platforms other than Kubernetes. We're then going to take a look at how you can make that work with containers on Lambda and some reasons why you'd want to do that, because it's not abundantly clear to begin with why that's something you want to do. And then we're going to combine everything together and see how we can put most of our stuff on Kubernetes, but then we're going to have some stuff on the side that stays on Lambda for various reasons. So these are the top OpenFaaS providers, and OpenFaaS is pluggable using a model that we call the provider model, which are separate processes with a single responsibility that talk to the gateway that you saw earlier. So we've got Kubernetes, Docker Swarm, Nomad, Fargate to run containers on Amazon, and there's some other ones as well by the community. So Alex showed you earlier on how we talk to the gateway through this REST API. We do send deployment requests, invocations, but the gateway itself doesn't have that knowledge, how to translate that concept to the target platform, because we're following single responsibility architectural patterns here, and we put that responsibility instead onto the provider. And it has a very similar interface, which we're going to look at in a minute. The provider then translates that concept. So if you're on Kubernetes, what does it mean to schedule a function on Kubernetes? It means you need a pod. To get a pod, you need a service and a deployment. And that's what the Faasnetes provider here knows how to do. But you can imagine you might be on another target platform, that's the light bulb, and you might have to do things differently. So if you're running on Lambda, you're not going to be able to create pods. You're going to somehow have to repackage your container and make it work on Lambda. So we're using the exact same model here, but I've written a new component called Faas Lambda, because I'm quite imaginative. And that knows how to translate that concept of container into a Lambda zip file. And that was really the hard bit here, was the repackaging. And it obviously needs to know how to talk to Amazon. So we're using secrets here that we'll then use to create a session in the AWS Go SDK. And when you deploy a function, it will assign that Lambda a default role. And we've got on our roadmap later on to be able to assign specific roles to specific functions. And these roles here would have least privilege principles. So this is that contract in code. And the first 5 functions are really CRUD functions. Deploy, handler, creates. Then we have read, update, delete. And function proxy there means please invoke my function and give me the result back. In the middle, we've got 2 little handlers for scaling up and down, quite self-explanatory. We have the ability to define secrets on the platform target. That's useful. That's allowed us to build common tooling further upstream. And we have health and version information. If you're going to create a handler to support Knative on OpenFaaS, this is what that deployment handler would look like. It's super simple. It's just an HTTP handler func. You get given the deployment request in the request. You'd unmarshal that, and then using the tools that you have to hand, talk to the Kubernetes API, create an API serving, and that in turn would create your pod in the Knative way. So it'd be really easy. You could probably do that in a transatlantic flight. I've done some of these on the plane. So this is a tweet here by the Stripe CEO, Patrick. And he's bemoaning the fact that there's so many different ways to make a payment. And this poor restaurant in San Francisco has had to get 6 or 7 different iPads in order to support their customers. And that's the kind of situation that we're in at work, is that we've got equivalent iPads to support Lambda CI/CD, Lambda log ingestion, and a different way to invoke Lambdas in our platform. And that's kind of annoying, because mostly we're doing standard Kubernetes-like deployments for most of our microservices, but we've got all these other iPads. So that got me thinking, could I get rid of these extra iPads? And this is why I've targeted this FaaS Lambda approach, because we now want to shift a lot of our Lambda functions away from Lambda onto Kubernetes to enable us to be multi-cloud, to be provider agnostic. And we can't do that if we have these extra iPads everywhere. There are some services like auto-scaling groups where you can't get away from using Lambdas, because that's the only way to hook into the event lifecycle. So we're still going to have some of that around, but we're going to limit that scope. But I don't want you to go away thinking, well, great, why don't we just all run OpenFaaS on Lambda? Because the best platform to run OpenFaaS on is clearly Kubernetes. Alex mentioned some of the benefits earlier on today. You've got great portability to enable multi-cloud, more control over timeouts and scaling. And of course, I don't need to tell the audience here at KubeCon the benefit of the Kubernetes ecosystem of software, commercial and open source, training, and people skills. So let's get to the nuts and bolts of this. How does the deployment lifecycle work? So we're going to send a request in to schedule a function, to deploy a function, sorry. And then when FaaS Lambda receives that request, it downloads the image from a Docker registry. It then uses a tool from Red Hat called Scopio. It extracts that layer, all the layers of that image, onto disk, because we need to reshuffle where vendor packages are, where function handlers are, into a format that Amazon understands. And then OpenFaaS handlers have a slightly different look and feel to Lambda ones. So we inject a shim here. And then finally, we zip it up and send it back to AWS. So invocation was quite a bit easier for me to handle, to write, actually. So all I do is I take the invocation request, then I use the Amazon SDK to forward that invocation to Amazon Lambda. And you'll notice here there's no API gateway involved. So that's going to enable you to have longer timeouts for your Lambda, and you'll pay less money. So at the top here, we've got the OpenFaaS function handler. And then this is a little shim that's necessary to run this on Amazon. This is all done automatically for you. This wasn't the hard bit, but it's more visually something to show. Similar thing that we did for the node template. For Go, because it's a compiled language, and because I just wanted to get something released, we took a simpler approach here, where we pipe the input and fork it into the function. But we've got on our roadmap to change this to either take advantage of Lambda custom runtime, or potentially to recompile that Go function with a shim injected. So we'll see what the community feedback is on that. So I'm going to show you a little demo of all of this working. Hopefully the demo gods will be kind to me. They have been the last 5 times I've practiced this. So we're going to take a function invocation, schedule it onto Lambda. That's going to examine a certificate, TLS certificate based on the host name, and then store the result in S3. And in step 2, we're going to fetch that result and display it onto the terminal. And we've assigned the IAM role so that that function has got permission to store in S3. Makes sense? OK. So we're running everything here on Kubernetes and DigitalOcean. You can see I've got the FaaS Lambda provider running, and I've got the gateway and the normal components. And I should have an empty function namespace, which looks good. And if I see on Amazon, I don't have any Amazon functions. I can also check that on here. So I haven't got anything in the gateway portal, I don't have any Amazon functions. Great. So if we just look at the function very quickly, it's a very simple handler. It takes the request as the host. It downloads this certificate. Hopefully you can all see that. Uses the Go TLS library, and then it takes the first certificate in that chain. Then further up, it translates it into some text, taking some useful information out of that certificate. And then down here, it saves it to S3 using that IAM role. And it returns the file name so that you can use that then to pipe into other commands. So we'll just go ahead and quickly deploy that. Okay, in this terminal, I've got the Lambda provider running, and you can see it's downloaded that container, and it's extracted those layers. It's reshuffled some of the folders, and then it's packaged it back up for Amazon. That will happen quite quickly. So then if we go and list the functions, we can see we've now got a function in Lambda, but if we use the normal tooling, we can see we've also got the function there. So I'm going to examine the certificate for Google there. And you can see that we've executed that function on Lambda using the normal OpenFaaS CLI tooling, which is really great. But we could also do this at the gateway level. So here the end user's got no idea that this is actually running on Lambda. The experience is all the same. We could even run it through the Lambda console itself. It's a little bit more awkward here. We have to create this sort of test thing. I should have one. But let's go and examine GitHub. We get the same thing. Not quite as nice experience. So one other thing I wanted to show to you was for this talk, I put together a certificate signing function, which takes, it's actually got a README. So it takes a CSR as its input. So you've got the host name, the key size, and you've got this handy UNIX epoch for how long it's valid for. And in the handler here, we go and sign that CSR, and it's going to create a self-signing certificate. So we generate a private key, and then later on, we generate the public certificate. And then we return that information to the user as standard out. So I'm just going to very quickly deploy this. See the layers coming down again. Extracting. It does it very quickly on this DigitalOcean cluster. It's much slower when I do this on my laptop. Now let's echo out that CSR. So we're going to ask for example.com. Cert sign go. Let's see how long this takes. This is a bit unfair. We're going to hit that cold start problem that you get with Lambda. Oh, that was actually quicker than I thought it was going to be. OK, well, it's 3 seconds. It's not bad. I suppose Lambda's not optimized for CPU-intensive functions. You can see here that that's now part of the deployed functions. Just checking that I am executing against Lambda. That was a bit faster than it's been before, but still, it's going to be useful for my demonstration. So we're just going to clean up before the next demo and remove these functions. Now we remove the certificate info, and then we need to remove cert sign. And now if we list functions using the Amazon SDK, you can see we don't have any anymore. So it's cleaned it all up. That's nice. And if we went back to the gateway, it's also empty. So what we've seen here, I hope you can appreciate that we're deploying containers, but we're translating them to the appropriate runtime, repackaging them in the Amazon format. And the cryptography performance wasn't great, but we wouldn't expect that. That's not what Lambda's for. So let's compare Kubernetes and Lambda running on OpenFaaS. So let's look at memory. Lambda's got this hard limit of 3 gigabytes of memory. That's not surprising. They've got their requirements. But over on the left-hand side, 12 looks a bit like 3 until you notice that that's terabytes. So I was able to find an Amazon EC2 instance with 12 terabytes of memory. I could use all of that memory running OpenFaaS on Kubernetes. The same kind of deal with CPU. By default, Lambda has 1 virtual core. If you allocate over 1.8 gigabytes, you get 2 cores. Obviously, with EC2, you could get a 72-core machine. Alex found a packet bare metal machine with 96 cores. You could use graphics cards, FGPAs, etc. So the Lambda timeout on the API gateway is 30 seconds, or if you don't use the API gateway and you're using events, it's 15 minutes. You have 290 years to finish your function on OpenFaaS, which is nice. That's probably how long my code takes to execute. There are also other restrictions around code limit size, the temporary directory. And I think, hats off to Lambda. It's a really easy-to-use platform. But I would argue that using sort of open source standard tooling, it's even easier to use. So this brings me on to the last component of my talk, is bringing this back together, because we don't just want to use Lambda, we don't just want to use Kubernetes. So I came up with, Alex and I came up with this idea of having a federation component. And this uses the exact same API as a normal provider, but instead we've added some smart routing logic into it. So it can determine the path to route or deploy a request to. So we can now target 2 different platform execution environments. It also occurred to us that you could use that concept to do a geo-split. So perhaps you've got data centers on the East Coast and the West Coast, but you want to have a single control plane to deploy your functions and execute it. Now, at this stage, we're just doing routing with this, and we'd like to get community feedback, talk to you guys, and see what you think would be value added to this, because we could imagine maybe doing more load balancing or circuit breaking could be useful there. So yeah, as I mentioned, some of these points, you've got that single control plane and the split, the execution environments, but we could also perhaps deploy based on CPU usage in a cluster or memory allocation, that kind of thing. I think the possibilities are quite endless. So I want to show you that federation example now. So we've decided that doing crypto is better on our EC2 instances or our DigitalOcean droplets on Kubernetes. So when we invoke this function, the FaaS federation component is going to examine an annotation on the function, and it's going to signpost it to use Kubernetes. So the request is going to go over there. With cert-info, it's less CPU intensive, and it does talk to S3. So it might make sense to do that as a Lambda, use some of your free credits. Again, here we have a different annotation that says, deploy me to Lambda. So it's quite simple, but powerful. OK, I'll very quickly show you that. So you can see here, just want to check that I'm pointing now to the setup where we've got the federation component installed. So I verified that. That's great. We'll just check that we've got an empty list of everything. Perfect. So we've got a different manifest file for this demo. It could be called anything. I've called it federation. You see here we've got the S3 function, and we've got that signpost down here to say, please schedule that on Lambda. And then we've got the crypto, and it says, please schedule that on Kubernetes. So all we need to do now is, again, using the normal standard tooling, deploy that. So we're going to see the same thing happen on here again. Then the second deployment is going to go over to Kubernetes and start a pod up. So you can see here now that it's getting it ready. It should be ready very quickly. So let's do that certificate signing request again and see if we get a speed difference. Well, that was 1 second, so that's already twice as quick. But yeah, so you can see it's a big speed difference. For the last week, I've been getting actually a 10 times speed difference, but you know, demo gods and all that. But we could scale up these droplets to be much more powerful. I've actually just chosen the cheapest ones. And if we just quickly invoke this one again, that's now being scheduled over to Lambda. But we don't know about these scheduling decisions as the developer. It's just transparent to us. But we could, to prove that that is actually happening, we can go over to the function in Lambda, and we can look at some of the metrics. So you can see this isn't smoke and mirrors. This is actually happening. Oh, it's decided not to load. What's the time now? There's probably some, this is UTC, so 9:55. Yeah, that was roughly now. So if we just quickly tear this down. You can see that's terminating the pod now. And it's cleaned up my lambdas. And you could have done all of that via the FaaS UI as well. I just chose to do it on the command line, so I find it easier. So to sum it up, what we've seen here is enabling multiple providers. So that's Lambda, Kubernetes, maybe Nomad. It doesn't have to be 2. You could have as many as you want. And we've seen the ability that you could target different geographical regions. But we use the same API at the front. It's a single pane of glass. Nothing changes. The developers, they're just building, compiling, and deploying Docker containers. So to get this working, I created, with the help of Alex and other members of the community, 3 new open source projects, which we're going to release at KubeCon later on today. There's an in-memory provider so that you can work at high altitude without internet. And we've got the Lambda provider, which you've seen in the federation component. So I think there's really a lot of potential here. I'll be interested to see where the community wants to take it. So sort of immediately next, I mentioned we're open sourcing everything. We're going to increase the template support. And at work, I'd like to deploy this to production so we can start getting value immediately. Thank you very much. Finished quite early. Got plenty of time for questions.
Yeah, I was going to say, any questions?
If you want. How long did it take to develop the software in this talk? It's difficult to keep track of sort of snatches of hours here and there. But I think I started this project at Christmas, and so that's sort of what now, 5 months, but I can only work on this, unfortunately, at rare occasions. Thanks. Well, we're here all week, as Alex mentioned. We've got the birds of the feather later on this afternoon. So yeah, it'd be good to chat to everyone about this concept. Thanks very much. Oh, so I've got a question there. Oh, okay, yeah. So someone's asked if they'd like to know more about the federation piece. So yeah, at the moment, it's just doing a routing decision based on metadata that's defined in the function manifest. And it's able to see that because it's in the request flow. So when a deployment happens, it can see that manifest coming, and it will capture that annotation, and it puts it in a map, in-memory map for the time being, so that when invocation requests come afterwards, it knows how to route it down there. But it's quite a nascent component at the moment. It's early days. Okay.
Any other questions? Oh.
Sorry, say that again?
The Lambda provider, does it support custom runtimes like AWS Lambda?
Custom runtimes?
Yeah, if I want to use Kotlin, Scala, or any other runtime that is not natively supported.
Yeah, so the question is, does the Lambda provider support custom runtimes? So at the moment, we've got support for Python, Node, and Go. And on our roadmap immediately, as you saw in the last slide where we're going, is to add support for the full community of languages that OpenFaaS uses, which would include languages like Scala and Kotlin. Yeah.
Can you repeat what Alex said?
Yeah, so Alex said that we could also take a look at supporting via the Lambda custom runtime, but at the moment we're not taking advantage of that. Yeah, so Trigger Mesh, they've got a project that uses the custom runtime. I think to give to run Lambdas on Knative. So it's sort of the opposite approach, but using that same technology.
Any other questions?